Welcome to Math with Mrs. Bibb. This week we'll be working on week 25. Within week 25 we will be dividing polynomials, and then we will be simplifying rational expressions. Unfortunately, this is our last week of the 2020-2021 school year. So there was much more to learn, but that's okay. That will be for another year. Please make sure to fill in your table of contents. We're going to talk about dividing polynomials. There are two ways to divide polynomials. You can divide using polynomial long division and synthetic division. Students always find it funny, the name synthetic divisions, because is it fake division? Synthetic is something that's not necessarily real. One of the big differences between polynomial long division and synthetic division is the fact that you can divide every single polynomial with long division, but you cannot use synthetic division on every single polynomial. So this is a method of dividing a polynomial by a polynomial. Typically, it's a polynomial by a binomial. That's typically what we divide by. But you can divide by a trinomial. That can be your divisor. And this can be used on any division. Please remember, though, that when you're dividing by a monomial, you do not have to do long division. If you have 5x squared y plus 4xy, and you want to divide by 2xy, then you do not have to do long division. You are dividing this term by 2xy and this term by 2xy. You do not have to do long division with that. You just divide each term by that monomial in the denominator. You do not use long division or synthetic division on a problem like I have written on the side. Now, synthetic division is a method for dividing polynomials. I should say a method of dividing, that's messy, a polynomial by a binomial. That binomial is your divisor. And there's two things that has to be true about that divisor. First of all, it has to be a linear divisor, which means the degree has to be 1. Second of all, it has to have a leading coefficient. I'm just going to put LC. You can put leading coefficient. A leading coefficient of 1. So first off, if your divisor is not a linear divisor, you cannot use synthetic division. And then secondly, if your leading coefficient is not 1, but you do have a linear divisor, you can divide everything by that coefficient to make it 1. I won't get to synthetic division, but on my YouTube channel there are videos about synthetic division, and you will be using that in pre-calc and in your college math class. So you may want to take a peek at that video sometime, or when you're learning synthetic division next year. You may just want to see my lesson as well as your teacher's lesson on synthetic division. Now, the remainder theorem is used pretty often and referred to pretty often. And what the remainder theorem tells you is that if a polynomial can be divided by a divisor, then the remainder is what you would get when you substitute k, so the opposite of this, into f of x. That's all the remainder theorem is. Now we're going to do polynomial long division. I want you to notice, I do need to point this out. This is the dividend. This is the divisor on every one of these. dividend and divisor. My divisor on number 1 is x minus 3. It's a linear divisor. So if I knew how to do synthetic division and my instructions did not say to use long division, then I could use synthetic division on that one. Number 2, my divisor is not a linear divisor. It is a quadratic divisor. So synthetic division could not be used on number 2. Number 3, my divisor is a linear divisor, but the coefficient of x, or the leading coefficient, is not 1. So I'd have to divide everything by 4 in order to use synthetic division if I wanted to use synthetic division. Then for number 4, my divisor is not linear, therefore synthetic division could not be used. But we're doing long division on all of these, so I wanted to just point that out to you, the difference between long division and synthetic division. You set up your problem. You put your divisor on the outside, the dividend on the inside. I write the steps over here. I advise on the first at least 10 of these that you do, and you can count these 4 as the first 10 that you do. I advise to write the steps on the side. It will help you to keep everything straight with long division. Okay, so I hope that as I record this, the writing, yes, there it comes. Something happened and my audio was deleted, kicked me out of the program, so I'm going to talk as my writing happens over there. The steps for long division with polynomials is the same as if you were doing long division that you learned in early elementary school or late elementary school. Divide, multiply, subtract, and bring down. So I'm going to use those same steps when I'm doing this long division over here for question 1. Step 1, we're going to divide. We're going to divide the first term of the divisor into the first term of the dividend. And that's what I'm about to do. So the first term of my divisor is x. The first term of the dividend is x squared. And I'm going to divide those, x squared divided by x. That's what I'm going to do. So x squared divided by x is going to give me the answer x. You put that answer above its like term, where you would generally put your numbers when you're doing long division. So you put it above 6x. Step 2, multiply. You're going to multiply the answer that you just got, that x, with the divisor. So x times x minus 3. I usually write it over there on the side. Once you get used to it, you quit writing it, but it's just where all these numbers come from. X times x minus 3 is x squared minus 3x. You place those answers under their like terms with the dividend. Next, you're going to subtract. You don't have to write step 3 and write the word subtract. I think I did here, but you don't have to. We're going to subtract. We're going to subtract those terms that we just found the answer to from the terms that were there. A lot of students would put the answer 3x. But when you subtract, you actually get 9x. 6x minus negative 3x is going to be 9x. And then when you subtract x squared minus x squared, that goes away, that gives you 0. And then the last step is to bring down. You're going to bring down the plus 12. And then you're going to start that process all over again. So I'm going to divide. I'm going to divide 9x by x. That's my next step. Start back over since I could bring something down. I'm going to divide 9x by x. 9x divided by x is positive 9. Don't forget to put that answer, positive 9, above its like term in the dividend, so plus 9. The next thing you do is multiply. You multiply 9, that answer that you just got, with x minus 3. So 9 times x minus 3 is 9x minus 27. So you use the answer you just got of 9 and multiply it by the divisor, x minus 3. And 9 times x minus 3 is 9x minus 27. Next you're going to subtract. I don't have room to write subtract over there. And hopefully you'll get 39 when you subtract. 12 minus negative 27 is positive 39. 9x minus 9x cancels out. That's my remainder. I have nothing else to bring down. So it's a positive remainder. I put a plus sign up there beside of x plus 9. And then I'm going to put a fraction bar. I'm just waiting for myself to do that. So I'm going to put a plus sign and put a fraction bar at some point. And I'm going to put 39 in the numerator and x minus 3 in the denominator. That's my answer. That's my quotient and my remainder written properly. X plus 9 plus 39 divided by x minus 3. I'm not sure if I discussed this earlier, why those divisors are underlined for number 2, 3, and 4. But I'll repeat it just in case I did not talk about it. There are two ways to divide polynomials, long division and synthetic division. You can use long division every time for every problem. For synthetic division, your divisor has to have a coefficient of 1, a leading coefficient of 1, and it has to be a linear divisor. So when I look at number 1 and number 3, those are linear divisors, so it is possible to use synthetic division for those. Although for number 3, there's a coefficient of 4, a leading coefficient of 4, which means you would have to divide every single term by 4 to be able to use synthetic division. For long division, for number 2 and number 4, you cannot use synthetic division because the divisor is a quadratic divisor, so you have to use long division. And somehow I ended up deleting the writing and the audio, so now I'm back to redoing those problems, audio and video. So I'm going to put the divisor on the outside, the dividend on the inside. I'm going to divide, I'll put my steps over here. I'm going to divide x cubed by x squared, and that's just x. And there's not an x term, so I'm going to add an x term and put x above it. Next, I'm going to multiply the answer that I just got by the divisor, x squared minus 16, and that gives me x cubed minus 16x, x cubed minus 16x. Next, I subtract. X cubed minus x cubed cancels out. Negative 4x squared minus nothing is negative 4x squared. 0x minus negative 16x is positive 16x. Next, I'm going to divide. Oh, I would bring down, but there's nothing there to bring down. But I am going to go ahead and divide. Step 1, divide negative 4x squared by x squared. And that would be negative 4. Multiply the answer we just got of negative 4 by the divisor, negative 4x squared plus 64. Subtract negative 4x squared plus 64. There's nothing out there on the end. You can put plus 0 if you want. Subtract negative 4x squared minus negative 4x squared is 0. 16x minus nothing is 16x. And 0 minus 64 is negative 64. Now I have nothing to bring down, but also when I go to divide again, Negative 16x divided by x squared does not work because it would leave an x in the denominator. So I know 16x minus 64 is my remainder. So I have a quotient, I'm going to write it above here, of x minus 4. Since my remainder is a polynomial, I'm going to put a plus sign and put 16x minus 64, remainder over divisor, x squared minus 16. And that's the answer to number 2. Moving on to number 3, divisor is 4x plus 1. Dividend, you do want to check and make sure that all of your exponents are represented. Third power, second power, first power, no power. If one was missing, you would want to put in a 0x or whatever that is. Let's say that this was missing, it wasn't there, then you would actually write 4x cubed plus 13x squared plus 0x plus 6. So every term has to be represented. But that x is there, so I'm going to go ahead and put 27 back in. Now I'm going to divide. I'm going to divide, I'll do my steps right here. I'm going to divide 4x cubed by 4x, and that gives me x squared. I'm going to multiply the answer that I just got by the divisor. And when I multiply, I get 4x cubed plus x squared. I'm going to subtract. 4x cubed minus 4x cubed cancels out. 13x squared minus x squared is 12x squared. I'm going to bring down the next term. I'm going to divide 12x squared by 4x. And that would be 4 goes into 12 3 times, x goes into x squared x times. So positive 3x goes up top. I'm going to multiply 3x times 4x plus 1. 3x times 4x is 12x squared. 3x times 1 is 3x. Subtract. 12x squared minus 12x squared cancels out. 27x minus 3x is 24x. Bring down. Divide. 24x by 4x. And that is 6. Positive 6. Multiply. 6 times the divisor, 4x plus 1. That would be 24x plus 6. When I subtract, I do not get a remainder, so the quotient is x squared plus 3x. Okay, for the next one, I'm going to put my divisor on the outside. And my dividend on the inside, x to the 4th, 4, 3, 2, 1. I probably won't need a plus 0 on the end, but I'll put it just in case. Okay, I'm going to divide. X to the 4th divided by x squared. That's x squared. Multiply x to the 4th minus x cubed. Subtract. X to the 4th minus x to the 4th is 0. 2x cubed minus negative 1x cubed is 3x cubed. Bring down. Divide. Divide 3x cubed by x squared. 3x cubed divided by x squared is 3x. 3x times x squared is 3x cubed. 3x times negative x is negative 3x squared. Subtract. 5x squared minus negative 3x squared is 8x squared. Bring down. divide. 8x squared divided by x squared. And that's going to be 8, positive 8. Multiply. 8 times x squared is 8x squared. 8 times negative x is negative 8x. Subtract. 3x minus negative 8x is positive 11x. And if I were to divide, it wouldn't work. So my quotient is x squared plus 3x plus 8 plus my remainder 11x over the divisor, x squared minus x. So that is the answer to number 4. Now moving on to the next slide. If you'll please get the definitions from Chapter 7, Section 3, page 376, for what a rational expression is and a simplified form of a rational expression. Hopefully remember a rational expression like we do rational exponent. If you have an exponent that's a fraction, that's a rational exponent. So a rational expression would be an expression, a rational or a fraction expression that has variables in the numerator and or the denominator, either one. If you look at simplifying rational expressions, looking at this first example compared to this example, you can only cancel out common factors if you have multiplication between them. Notice you have on the bottom example 4 times the quantity x plus 3, and in the denominator x plus 3 times x plus 3. You can only cancel out one of the x plus 3's, and rational expressions have to be in factored form in order to simplify them. To multiply them, you just multiply and then simplify. Multiply numerator times numerator and denominator times denominator and simplify when you have just monomials. When you're dividing and multiplying, when you have binomials and trinomials, you want to make sure they're in factored form, and then you can reduce. I want you to notice where it says x cannot be 0 and y cannot be 0. And down here it says x cannot equal 3/2. The reason is you cannot have a 0 in the denominator. So you have to make sure that you indicate that you can't have 0 in the denominator. The 3/2 comes from this right here. X can't be 3/2 because of that fraction right there, or that expression right there. Now we're going to simplify. If you notice, all of those are, well, I'll take that back. Number 1, the numerator has a binomial and the denominator has a monomial. Same thing for number 2. Number 3, I have 2 trinomials, and number 4, I have a binomial and a trinomial. Anytime you have binomials and trinomials, you want them to be factored before you simplify. Don't forget that. So I'm going to factor the numerator for number 1. There's a greatest common factor of 2x squared. When I divide away 2x squared, I have x minus 4. And then my denominator, you cannot factor a monomial. And now I have nothing to reduce with x minus 4. So x minus 4 is going to stay x minus 4. But 2 and 6 will reduce to 1/3. So I'll put a 3 on the bottom. And then the x squareds would cancel out. So my answer, even though it's kind of off center, my answer is x minus 4 over 3. It could be written like this. That is the finished or final answer for number 1. For number 2, I'll take out the common factor of x y squared. 5xy cubed divided by xy squared would be what? 5y. negative 2x squared y squared divided by xy squared, I believe would be negative 2x. And then I need to reduce. X and x squared will reduce and leave an x in the denominator. By the way, 5y minus 2x will be in the numerator. And then the y squareds will cancel out. And the only reason why I can cancel those y squareds is because they're both in a monomial. I can reduce the x and the x squared, and then I can cancel the y squared and the y squared because they're both monomials. And please notice that I cannot reduce away, let me highlight, I cannot reduce away this x with this x. The bottom x is a monomial, and the top x is in a binomial, and you cannot reduce those away. Now for number 3, I have to put both trinomials in factored form. A times c is 4, sum of b is negative 5. So that would be negative 1 times negative 4. A is 1, so I can factor this the quick way. X minus 1 times x minus 4. For the second one, I need a times c is 1. Sum of b is negative 2. So that would be negative 1 times negative 1. So x minus 1 times x minus 1. Now I have all binomials, and I can reduce any that are alike in the numerator and the denominator. So this x minus 1 could cancel with either of the x minus 1s in the denominator, and then that's all that I can cancel or reduce. The simplified answer for this expression is x minus 4 divided by x minus 1. For number 4, I have a binomial in the numerator that has a common factor of x squared. X cubed divided by x squared is x. 3x squared divided by x squared is positive 3. In my denominator, I have a trinomial, a times c, sum of b. I think that's negative 8 and positive 3. So that's going to factor into x minus 8 times x plus 3. Can I reduce anything that's alike in the numerator and the denominator? Yes. These two binomials are the same, so I can reduce. And there's nothing else I can reduce. Please, please, please remember, you cannot reduce the x squared with the x that's in the binomial in the denominator. You cannot do that. Moving on to the next example. Now I'm multiplying or dividing, whichever one is specified. What I'm going to do is just multiply straight across, because I have monomial divided by monomial times monomial divided by monomial. So I'm just going to multiply straight across and get 3xy squared, and then I would get 2x squared y squared. Then I'm going to reduce. The 3 and the 2 are reduced. X and x squared reduces and leaves an x in the denominator. The y squareds would then reduce away and would leave the final answer of 3 over 2x. For my next problem, I have a division problem, so I need to rewrite that as a multiplication problem. Remember, you leave your first fraction alone, you change divide to multiply, and you do the reciprocal of that second fraction. Now when I multiply in the numerator, I'm going to put y times x plus y. I'm not going to distribute. And then in the denominator, I would have 28x squared y. The only thing that I could possibly reduce would be this monomial with something in this monomial. The x plus y, I cannot reduce anything, so the x plus y remains, and then the y in the numerator and the y in the denominator would reduce away, and I would only have divided by 28x squared as my answer to number 6. For number 7, it's already in factored form. We would want to put it in factored form if it wasn't, but it's already in factored form, but I need to multiply by the reciprocal. Keep your first fraction the same. Change divide to multiply, and then put what's in the denominator in the numerator, and vice versa. Now, what I'm going to do first is see if I can reduce anything in each fraction. And the first fraction is okay. Then the second fraction, the x minus 6, I can reduce away. Then I'm going to put everything in the numerator that's in the numerator of each fraction. I'm not going to physically multiply. I'm going to leave it alone. And then put everything in the denominator. And then see if I can reduce. And I do see that I can reduce these away. And that's it. I have a monomial times a binomial in the numerator. And I have a binomial in the denominator that cannot reduce with the binomial in the numerator. So that would be my answer. For number 8, it's already multiply, but I need to factor. Both numerators and both denominators can factor. So the first numerator, factors of -3, that will give me a sum of -2, would be -3 times 1. So I would have x minus 3 times x plus 1. In the denominator, I have a difference of squares, two empty binomials, one with a plus sign, one with a minus sign. I'll take the square root of x squared, that would be x. I'll take the square root of 1, and that would be 1. And then for my second trinomial, I want factors of -63. That will give me a sum of -2. I think that's -9 times 7. And then that would factor into x minus 9 times x plus 7. Then my second denominator, I'm going to factor -21. That will give me a sum of 4. And I think that's 7 and -3. So I would have x plus 7 times x minus 3. Now look at each of your fractions and see if you can reduce anything from the numerator and denominator. The first one, x plus 1s will reduce away. The second fraction, the x plus 7s will reduce away. So I'm going to have x minus 3 in the numerator along with x minus 9. And then I will have x minus 1 in the numerator along with x minus 3. And then I need to reduce, so the x minus 3's will reduce, and my final answer will be x minus 9 divided by x minus 1. Okay, moving on to the next slide. We have 2 more to go. Same stuff. I'm going to factor. I only see 2 numerators and 1 denominator that can factor. The first numerator has a common factor of x. My first denominator is good. It will not factor. My second numerator is a sum of cubes. So I'm going to put empty binomial, empty trinomial, use SOAP, same sign, opposite sign, always plus. Cube root of x cubed is x. The cube root of 8 is 2. The first spot is the first term squared. The last spot is the second term squared. And the middle spot is those 2 multiplied. And then in the denominator, I have a common factor. Actually, I think we're going to have a difference of squares, so I'm going to write this here. If I take out x, I'll have x squared minus 4. Yes. And so then I have a difference of squares, a plus and a minus. The square root of x squared is x. The square root of 4 is 2. And then, can I reduce anything in the numerator and denominator? My first fraction is okay. My second fraction, the x plus 2's can reduce. Now I'm going to put everything together. X times x minus 2 times x squared minus 2x plus 4. That's in the numerator. In the denominator, I'm going to have x. I always like to put my monomials first. X, x plus 7, and x minus 2. Can I reduce anything away? Yes, the x's can reduce away. The x minus 2's can reduce away. So my final answer is x squared minus 2x plus 4, and that will not factor, divided by x plus 7. And that's all I can do to that problem. And now I have 4 trinomials that I'm sure can factor. So I'm going to have factors of negative 15 that will give you a sum of 2, and that will be 5 and negative 3, x plus 5, x minus 3, and then I'm going to factor and get factors of negative 40 that will give me a sum of negative 3. I think that's negative 8 and 5, x minus 8, and x plus 5. I'm going to go ahead and do the reciprocal. So this will go in the numerator. Factors of negative 72 that will give me a sum of 1. And that looks like it would be negative 8 and positive 9. So x minus 8 and x plus 9. And then my numerator in the beginning problem, the second numerator will go in the denominator. I need factors of negative 9 that will give me a sum of 8. So factors of negative 9 that will give me a sum of 8 is 9 times negative 1. So x plus 9 times x minus 1. And now I'm going to reduce. I see in my first fraction these two will reduce away. And I see in my second fraction these two will reduce away. So in my numerator I'm left with x minus 3 and x minus 8. In my denominator I'm left with x minus 8 and x minus 1. And x minus 8 cancels out. So I have x minus 3 divided by x minus 1. That's my answer to number 10. And moving on to the last slide. It's not really any kind of instruction. It just tells you the problems that you need to do. Those are your final problems that you need to do for Algebra 2 Honors. I would like to say that if you need or would like to continue learning, I have lots of videos of things that I taught the Algebra 2 Honor students last spring when we were in quarantine. So if you would like to continue that to prepare yourself for pre-calc, then you're welcome to do that. Just go to my channel, YouTube channel, and watch those videos. Number 40, I've kind of given you a hint on how to answer number 40. So I hope that this video helps you learn your final concept for Algebra 2 Honors. It has been a great year